All right, hello everyone. Welcome to yet another day of ECS 179 gameplay programming. Have a seat. Am I loud enough in the room? Can you all hear me? We good? Thank you. It's very hard to tell in this room whether it's mic'd or not. So today, we're going to go over a few things. We're going to have some cleanup to do. So first, I want to go over office hours. I want to go over potentially getting folks more help on exercise 1. I want to take questions you have on exercise 1. I want to go over the key for exercise 1. Then we're going to get started with some information about camera controllers for exercise 2. We're going to start prepping exercise 2, which will be assigned next Tuesday. And then we're going to play some games and talk about gameplay systems. Today, by TA selection, we're going to play some Chrono Trigger and talk about what its gameplay systems are and how potentially to implement them and what their borders are. Look at them through a technical design perspective. And we'll be taking volunteers to play. All right. So first, I want to talk about office hours. So if you look on Discord, you'll see in general that there is a message about when office hours are. These are my office hours. Kyle has separate office hours. So for my office hours, I have two options. Wednesday, 11 to noon, and Fridays, 11 to noon. So there's a reaction. So there are actually 3 reactions. First, I had office hours that actually overlapped with Kyle's. I did some bad scheduling there. And so option 1 is off the table. That's overlapping. Options 2 and 3 are, Friday and Wednesday. It was just a weird artifact of how I put the poll together. So all you have to do is react to either 2 if you can make the Friday time, or 3 if you can make the Wednesday time. And I'll set the office hours for which one has the most votes. All right. As a reminder, Kyle's office hours are on Wednesdays at 1 to 2. We had a successful office hour last time, it looked like. Excellent. Now, I realize that exercise 1's coming up, and some of you may not be able to have the office hours that I will be holding Friday at 11. No matter what the poll says, this Friday, I will be offering office hours at 11. There have already been some people that have approached Kyle and I about, hey, I can't make any of these office hours. I'm president of too many clubs or something, right? I have way too much pickleball to play to go to office hours, so I need some special office hour times. So we have traditionally done ad hoc office hours, like in the evenings. I'll often chat one-on-one with people, do a screen share, talk about problems. But we are thinking about having a special get bootstrapped and get your progress done on exercise 1 hours either tomorrow or Monday. So I guess that is Kyle's decision. Do you want to say anything about that?
I think I can ideally hold an extra, thank you, an extra set of office hours tomorrow from 1 to 2. My Monday is not so good, so I could do 1 to 2 tomorrow. I'll make an announcement about it. Drop by if you can. I'm also happy to answer ad hoc questions on Discord at reasonable hours. I'm not usually a night owl, so send me your questions, at me, whisper me, whatever you want to do. I'll get to them when I can. All right?
Thank you, Kyle.
Thank you.
And as a reminder, we are using Discord. So if you DM one of us, first we have to see it and accept it, right? There's the filter.
That's right.
And then we have to know who the heck you are, because DMs don't preserve your nick on the server, right? They're server orthogonal. So make sure you tell us who you are. All right, any questions about these logistics before we get started with looking at the key, looking at the end performance for exercise 1? It doesn't look like anything's percolating, so we will take it from here. So, getting prepped for this. So I sent out an announcement that had various bits of information about Exercise 1, including the compilations of the announcements we have with information. So as review, let me open up my browser and show what's going on. So first, importantly, Discord. I think all of you are on it by now. If not, time to join. Let us know if you need an invite. The attendance form for today, as a reminder. But the two things you're going to look at are the Google folder for lecture recordings and the YouTube playlist for lecture recordings. We have two ways for you to get those. Let's say you're going to take a train and you want to watch a lecture recording and the train Wi-Fi and or cell signal is very bad. You can just download the videos to your local disk. It's hard to stream the videos from Google Drive, which is why we have the YouTube playlist, which is much better at streaming. Hey, 60 views on Exercise 1 discussion. So I may post a second last year's discussion section on this. I was on quite a bit of cold medication that day, so some of it is a little loopy. Let me know if you need clarifications. I reviewed it and I did ramble quite a bit. Apologies, I'm happy to clarify. 'Tis the season to have respiratory illnesses, right? Turn the, yeah, if someone maxes out the volume in here for every class. I need to start checking. All right, so hopefully the videos have been useful for you. I've been trying to update them, as quickly as possible. Sometimes it takes a while to encode, sometimes it takes a while to upload. Sometimes I'm going from meeting to meeting and don't have time to upload a 500 megabyte video, but we try to do the best we can. So note the additions, the Unity tutorials are now here. Thank you, Kyle. Exercise 1 discussion and last lecture. On the syllabus, interesting things here are a link to the command pattern reading by Nystrom. We talked about the command pattern, but here is the game programming pattern example of this. It is in C, but the code translates well, the ideas translate well. All right, it's in C++. I'm sure all of you have experienced C++ at this point. If you are C++ fluent enough to understand these examples like this, can I see a hand? Okay, that is the vast majority of folks. But there are still some who did not raise their hand. It looks like that may be the same set of people last time that raised their hand when they needed some review of object-oriented programming. So that's also a good thing to come to office hours for. I'm happy to help you understand hierarchies, interfaces, inheritance, class encapsulation, the basic ideas of object-oriented programming. If you don't have that level of knowledge, or you need that knowledge sort of buffed up, we're happy to help you do that. It's critical knowledge for the class. Particularly, you're going to be using a lot of generics, you'll be using a lot of data structures, you'll be using, classes upon classes, hooked through interfaces, through component systems. Understanding the core behind this concept is critical. So please get that information from us during office hours. We're happy to help. But it's not something, this is maybe a fifth of the classes in this case, so it's not a push mechanism, it's a pull mechanism from you. All right, has anyone done the reading yet? Yeah, the command pattern reading. Yeah? Oh, more hands, please. Okay, fine. It's a really cool book. I really like this book. That's why I gave it to you. Check it out. It's very handy. I'm sure you'll find some joy. All right. Last is the command pattern exercise itself, getting things rolling. How many of you have made your GitHub Classroom accounts and gotten your own repository yet? Okay, good. That's good. We got the majority of hands, the vast majority of hands up, super majority. Excellent. Was the process smooth for you? It's pretty streamlined, I think. And as a reminder, we said this a few times in class. It's in the assignment description. It's in the announcements that we sent out. Your turn-in mechanism is simply to have your code present on the master origin branch. So on the repository on GitHub that we have generated, that GitHub Classroom generates for you, your turn-in code should be there by next Tuesday, 11:59 p.m. Yes.
So I have a question about exercise one. So
Yeah.
are we allowed to modify those environments like the mushroom forest, like those images, or maybe add like a collision box or something to it? Are we allowed to do that?
Yes, but if you make modifications that will affect the assessment of steps 1, 2, and 3, step 4 is a little open, right? If you are changing that basic gameplay, we need an explanation. So put it at the top of the README. We have to know what's going on there. So we want to do a fair assessment. If you go and make something cool, but you mess with the original gameplay, we need to make sure you understood those first concepts.
So even if that thing is already related to like part 4, we still like need to mention it in the README file, or like we can also just like add a comment at like the script we created for part 4.
Yeah. So you make some design changes, play with it, and make cool things happen. I'm happy to support that. We just need to know that it wasn't just like haphazard coding errors that caused the changes, right? We want to know it's intentional and designful. So we just need some textual explanation. Usually putting it at the top of the README is the go-to place for when these things occur. You're welcome. Good. I'm looking forward to seeing what you come up with. All right. So as a review, we're looking for stage 1, both legs. So you want to move right as well as left. The guide for this is quite simple. You simply you make a copy of the code of the move left command and rename it move right and have it move in the appropriate direction with the appropriate sprite flip. Right? This is to get you started. You're making your own code file, you're in Unity, you're making a new script, you're in Unity, you have to put it in the right folder, put it in the assets scripts folder, and then you hook it up with the command pattern. You hook it up to the Captain controller. Get you started. HEFO is a little more complicated. We traditionally have questions about this. Does anyone have any questions about what exercise 2 is asking of you? Yes.
So it mentions like a 20 to 40 second duration. Is that a case where it's like a range for random timetable or something you just choose?
Yes. I thought I had a link to random here. So you can use unity.random. You can use C#'s random. Both work. There are other cases that have random that we've shown you already. So the PCG tree used random. If you call system.random, it will give you a number, or random.value. It'll give you a float between 0 and 1. Well, how would you map that to a value between 20 and 40? Yes.
You multiply by the range of 20 and 40 and then add the minimum value.
Exactly. So you would multiply system.random.value by 20 and add 20 to it. So it'll give you a value between 20 and 40. Right? This is a classic set of like space normalizations, space mappings. We'll talk about that more discreetly, particularly for exercise 2, but this is a common tool. Mapping a space from 0 to 1 to some other range. Great, that's what we're asking you to do here. First one's between 20 and 40, then 10 to 20, then 5 to 10. There's often these stochastic elements to games. So we're giving you a slice of that right here, right now. Now we've had some questions about no work pirate command. So after you write stage 2, no work pirate command, that code that I gave you, won't really be used in your code at all. Right? No work pirate command. Let me pull it up in Unity. Here we are. Why can't I see it all? There, now I can see it all. We have no work pirate command. So this class right here, it's a little big. We can make this a little more legible. No work pirate command. This class basically just returns false, right? It's making the pirates in idle state or exhausted state the entire time. Just like your slow, normal, and fast work commands will do when their time is elapsed. This really is a template for you to build your slow, normal, and fast work commands from. This is why we provide it. This is why there's these variables that aren't used in the reference solution. These are the variables we used. Take them or leave them. Use whatever variables you want, but here are some things to get you started. Right, the responsibilities you have, making sure the execute, which is ran every update, making sure that returns true when the work is happening. That's thing one. False after that time after the total work duration has elapsed. Number two, you will be spawning the product prefab, the object that is passed in on execute. You'll be spawning one of those for every 2, 4, or 8 second duration, depending on which Captain Work command you are in. Right? So you have one larger global timer, and you have one sub timer that gets reset. And you should make sure that after your global timer is finished, your total work timer, your product timer, the 2, 4, 8 second one, does not generate after the global timer has elapsed. Right? So this is why we give this to you. This is just a framework, a template for you to work from. Take it or leave it. You don't have to use any of this. You can construct your own. But this is to help out a little. Yes?
How come there's a constructor? Because it inherits from scriptable object, right?
Yeah, scriptable objects can have constructors because they can be used normally as classes. Really, I really thought hard about removing that. But when I removed it last time, it really confused a lot of people. And people didn't know where to put the initial selection, the initial randomization of the total work time. So another thing you do here is on enable. That can be used in place of the constructor. And that's more idiomatic for Unity in scriptable objects. Yes?
What's the purpose of it?
So it works kind of like a constructor for scripts in scriptable objects. Start is when Unity starts up. On enable is when objects are enabled. So you can actually disable and enable game objects. And so every time it's enabled again, that code will run. So start runs once. On enable can potentially run multiple times. But typically with the use cases we've had so far, on enable is kind of like in use, synonymous to start. So here you can put, your system dot random dot value calls. All right. So was my goal on demystifying stage 2 successful? Do you feel a little more apt, a little more armed to handle that particular challenge? All right. So time.delta time is something you want to use. I want to make a caveat on time.delta time. We explained a bit last time. So time.delta time is the amount of time that has passed from one update to the next update. So this tells you how long it's been between this frame and the last frame. It's the delta time between frames. So you can accumulate those and start counting up towards a timer. This is your basic mechanism of time accounting in an update cycle world. Time.delta time is not thread safe. There is a version of time that works well with netcode, just throwing it out there at the beginning in case you use multiplayer enabled code or you use multi-threading, use the C# job system, you'll have to use a slightly different delta time call. But this is the basics. And it gives you a float, a fraction of a second. Some systems, like Java, for instance, and probably Python, I think give you milliseconds. Maybe microseconds in the case of Python. Now I'm forgetting Python's time signature, the time functions. But this is a float fraction of a second. Hopefully a fraction of a second. Hopefully your performance isn't as bad as maybe the overloaded collection Nova example from last class. All right. Now, does anyone need any clarity or any examples on how to make a timer? Is this something you think you can do? Do you feel comfortable over update calls to execute, or over update calls that call execute through the captain or through the pirate controllers? Do you feel comfortable in accumulating values and comparing them to total work duration and product timer durations? Okay. If not, ask questions in Discord. I'm just trying to cover all the bases here. I want you to be successful. All right, is everyone comfortable with generating a new instance of a prefab, either the mushroom, the gem, or the skull? Good, we gave you enough examples of those, like in the PCG tree to, excellent, great. Stage 3, motivation will continue until work improves. Are you, so basically we have the right-click fire command, which is motivate, is the captain motivate command, which swings the sword, which activates that secondary motivator hitbox, which is quite big. That sword chop has quite a reach to it. If that intersects with a worker's hitbox, collides with, then we send a message. We call the motivate function in the pirate worker controller. And so that's where your code will go. So when that function is called, right now it's empty. The one I gave it to you is empty. You'll have to fill it in with generating a new instance of one of your work commands to be that pirate's current work command, active command. Okay. So repeat some of your code. And stage 4, do whatever the heck you want. You want to see one of those? Let's see one of those. Get out of here, Zoom. I don't want to authenticate to you today. All right. So here's one example from a student from last class. One moment. Build the correct one. I did not. That one should be it. Do any of you have ideas on what you're going to do for your stage 4? For your Fire 2s? Anything fun? Or are you all like keeping it close to your chest to surprise everyone? All right. Make sure the sound settings are appropriate here. So those noises were things being generated. Start off with the slow work command. Let's motivate. 2, 3, 4. So now it's normal work command. See mushroom generate every 4 seconds. And idle. And so what you do is we'll go through here. We'll see. Everybody should be idle at this point. Gyms, go. Alright, so as you probably saw, this person decided to make a dash command. Which wasn't cleaned up on the teleport, right? So you can see when you teleport, the dash commands look crazy. And it also isn't quite on the right depth layer. Doesn't have quite the same depth value, so you can see it'll sometimes overlap with the background. And it depends on which direction you're going. Alright, so that was an interesting one. And you see we're accumulating score. Right. We have move left and right. We have pirates doing different work commands. Let's see if we can get a fast work command. There we are. Once every 2 seconds. And then fast is. So as a note, if you're tired of hearing the music, you can open up the music controller. So you go to Assets, Music Controller, and here is where you can set the volume. So you turn the music all the way down. Maybe not long. There we are. You turn the music all the way down, and you won't hear it anymore. But so are the other attacks, right? So we have a full music balancing, or sound level balancing. And we have some custom sound scripts, Sound Engine, which you can look at if you want to take a peek. Happy to explore during office hours. All right. Now you've seen how it should work. Any questions? Yes.
Yeah, so one question is about stage 3. In the description you said like it should you randomly assign a new instance of like one of those 3 work patterns. But,
Yes.
Yeah, so but like in your like presentation it shows like it moves from like slow worker to a normal worker then to like a fast worker.
That just happened to be how the dice rolled.
Yeah, so it's just like happened randomly, right?
Yeah. So what you'll do is on Motivate, you'll use the random command, system.random, and generate a value of 1, 2, or 3, corresponding to slow work, normal work, or fast work. That's one way you can do it.
So like whenever you like motivate the pirate, like it generates a new work randomly work pattern, right?
Yes. Yep. And if you want to put some bias in that randomness, that's fine. By default, most people just make the odds of having each one the same as all the others. But you could make like fast work only happen 10% of the time if you wanted, right? Yeah. So it's up to you to balance that table. It's a point of game balance that you'll often see. Treat it like a D&D encounter table. Yes.
So for the motivate function, in the game, if you hit them again while they're already working, the behavior we want is for it to reset, right? So then, like if you just spam motivate, they'll never produce anything.
Exactly.
Correct.
If you had your pirate captain hacking you with a sword or you're trying to harvest mushrooms, you probably wouldn't produce any mushrooms either. It's a realistic sim. It's basically a life sim. This is capitalism simulator. Good point. Any other questions? All right. I know some of you have this down pat, but some folks need a little extra help. We're just having little kitty gloves on the first assignment to help folks out, to get folks rolling. Any last questions? All right. Good luck on this assignment. I'm looking forward to seeing what you come up with. All right. Now, we're going to take a look at Scrollback, the theory and practice of camera styles. Beate Kurin. Let's see here. So this was one of the more interesting talks at the Independent Game Summit at the Game Developers Conference in 2015. So this was one of the first times someone has done sort of like this deep dive, ontology-rich comparison of two-dimensional camera controllers. Why two-dimensional camera controllers for us now in this class instead of three-dimensional camera controllers? Well, three-dimensional camera controllers are much more varied. The ontology is harder to distinguish, and they're much more complicated. So we're getting a foothold into this space. We're going to be looking at two-dimensional camera controllers in order to understand the qualities, the math, the examples for this space. That way you can start understanding like what makes a good camera controller in 2D, and then you can start extrapolating into 3D. I have resources for 3D camera controllers for you as well, but this is a really, I think, succinct, compelling overview of 2D camera controllers. And it so happens you'll be implementing some of these 2D camera controllers for exercise 2. All right. So you can look at the overview of this. There's some sections on the neural background of controllers in motion. Feel free to check that out. I'm not going to emphasize that in this class. You'll be not responsible for the biology of eyes and ears for this class. But this is important. Attention, interaction, and comfort. Right? These are the basic things you need to balance in a two-dimensional controller. You have to have your ability to perform well as a player, to do what you need to do in the game, during gameplay, through your interaction. So the camera controller needs to show you things that are relevant, and it needs to move in ways that are relevant. If it moves too quickly or snaps too much, it may actually impede your ability to see. It may be too jittery or too fast for you to really process what's going on. So there's comfort, there's basic processing capability, there's allowing you to pay attention to things on the screen that you need to pay attention to. All of these have to be balanced. And this is a thing we've been doing for a long time. Back to arcade games. You could argue that the first set of the first video games had camera controllers. They were just completely static. Tennis for Two, Pong, Tennis for Two, game on the oscilloscope, Pong, Space War. All of these had a static screen. Camera didn't move, right? So they're not too interesting for us to talk about. But once we start getting into the arcade games of the 80s and then the console games of the 80s and 90s, the landscape becomes much more varied and rich. Like Rally X, 1980, Namco, Scramble, Jump Bug. Let's see, maybe I should make this just a little bigger so we can, okay, maybe that was a bad idea. Okay, we'll just deal with this. All right. So the first one we're going to talk about, following the action. This is a position locking camera. Right, we didn't have a lot of resources to work with. Games were a little more simple. So what did we do? Well, we pegged the camera to the center of the avatar the player was controlling. In this case, a rally car moving through a maze-like space. Right? So position locking. Locking the camera to a position of an entity or an object. What do you like about this? Yeah?
It tells you very clearly where you are.
Yeah.
Nothing more than markers in terms of gameplay.
The center of the screen is oriented around the thing the player is controlling, right? What else is good about this? Yep.
Since like you are at the exact center, you have a clear view, equal clear view of all directions of what is around you.
That is an attribute. We'll talk about whether that's good or not later. But that is, for this portion, it's not a bad thing.
Yeah.
Yeah.
It's very predictable. Like, I kind of like the ones later. Like the camera might move to different places, but this is like it's just static. So you always know exactly how the camera's gonna move and where you're gonna see.
Yeah, so if you were like a speed runner, you could use just the very edge of the camera to get like the smallest bit of pixel information for what you need to know to make your path as short as possible, right? So you can effectively plan around the camera since its properties are very clear. What's bad, or what else is good about this? As a programmer, what's good about this? Yes.
You don't have to like program controls with the camera. It's like following the camera.
Right, the control logic is dead simple, right? Peg it to the center of the thing you want to follow. Right? Doesn't get too much easier than that, right? That's what's good about this. What's bad about it? What's bad about this camera?
Any like micro movement or movement at all is just overemphasized.
Yeah, I'm already tired of watching it, right? It already hurts my eyes. It's fatiguing as you bounce around. Yes, Kyle.
Doesn't generalize to multiplayer.
It doesn't generalize to multiplayer. Yep. Couch co-op.
Super Mario Wonder.
Wonder.
Playing that game. I hate not having the crown. So you don't have the crown, camera doesn't follow you.
Is the elephant a good gameplay move or a bad gameplay move? What do you think?
It's interesting.
It's interesting. Okay. Let's destroy all the game mechanics and run right through it. All right. So that's position locking. We have other versions of this. So there's been more nuanced position locking. This is position locking with edge snapping. So this is Kung Fu Master, 1980. Right? So we're position locked. But how is it position locked? It's a little different than Rally X. How is it different? Yep.
Once you reach the end of the screen, it stops snapping.
Right. So it snaps after a certain location in the level is located. What else is different? There's one more major thing.
It's only locked on like the x-axis.
Exactly. It's not locked on the vertical, on Y. Right. So that was a very particular move for this game's level layout and decisions. Position locking still works pretty well. How many of you played Terraria? Right, I imagine this is a pretty common game, like 2D Minecraft, a little more story. The grappling hook is really fun. But position locking still works well to this day. Now, what about Terraria makes position locking good? Like, why is this a good choice? By 2011, we had a ton of different camera options. Why do you think this in particular chose position lock? Yes.
So that we can distinguish our position from other functions.
Yeah, so we can it makes it a little easier to distinguish distance, which is great. Yeah.
I feel like Terraria in particular has a lot of like freedom of movement. So like moving like everywhere.
Yeah.
So I guess it will help knowing where everything is. Like,
Exactly. You can move everywhere, which is really important in a game where just about everything could be important, right? So what are you going to put your attention on? It's probably very hard for a camera controller to know that detail, right? Another thing is looking at the graphic design of this, the layout of elements. The screen is moving relatively slowly compared to the examples we've had so far. The pixel density is much higher. There's a set of inertia and physics to the player itself, and the player is relatively small compared to the world around it. Right? So that really makes this a good choice because you're having all the benefits of position locking without the major drawbacks, which is jitter and eye fatigue. Right? The jitter is minimized because there's physics in the control. There's momentum in movement. which automatically, by being position locked, has that smoothness to the camera scroll by virtue of the player scrolling more seamlessly through the world, as opposed to the snapping harshness of 8 degree of freedom movement in Rally X on a small pixel count screen. Right? All right. Now, even on the small pixel count screens, there were some solutions to this jitter, to over movement, to unpredictable bumps and nudges and jitters. This is a camera window. It's a push camera. Can someone describe me how this thing's working? Have you divined its inner workings here? It's not super complicated. I'm pretty sure someone can synthesize on the fly. Yes. Exactly. The push box metaphor is directly appropriate. When you hit the edge of the box, when you move it, you push that edge, and that pushes the camera. So the camera is locked to the box, but the player can push the box. All right. So this is used. We'll look at several examples of these. This is Rastin Saga, a really stylized Conan the Barbarian inspired arcade game that was a real quarter sucker back in the day. Now, I really like this example. This still uses a push box, but how is it different than the last push box? Yep.
Tries to give you a better view of the bottom behind the screen.
Yeah, right. So the push box is a much smaller fraction of the screen in the top left. So why would they want to give you a better view of the bottom and the right? Yeah. Right? You have a lot of information about what's coming on the bottom and the right. And, you know, they sort of like leverage that in environmental design, right? There's a lot of empty space for you to look at. Your eye is drawn ahead where the pretty things are. Right? So this game was known for its environmental design. It had a really good pixel art for the time it was released. And they were trying to show that off. Now it's also a quarter sucker. What else does this camera give? What other gameplay properties does this camera give? Yeah.
Does it make it easier for the game to ambush you?
Exactly. Things coming from behind or from above you, you have much less reaction. You have much less space to react, or much less time to react. Many fewer seconds. Right? And so that makes things like, let's see if there's an example here. So you'll see a character coming from behind. There was probably about half as much time to react to that green lizard person coming from the left as opposed to the green lizard person coming from the right. So you can set up ambushes, right? So this is attention, this is reaction time, this is information play with your player based solely on the design of the camera controller. It gave level designers another thing to work with. Fez. Do we have any Fez players? Anyone play Fez? Yeah. Okay, this game won a lot of awards. It's very interesting. So this one has position locking and region snapping, but it also has physics-based movement, right? So here you're pushing the left and right edges, but the horizontal, what's happening with the horizontal aspects of the camera, up and down? How is it different than the other examples we've seen? Is it big enough? Can you all see it in the back? Yeah. Right? So it is eventually position locking that horizontal line to Fez's feet. Right? But it does it after a while. There's a delay. It has physics smoothing to it. it does a linear interpolation. So a change of values over time where you want the camera to eventually interpolate to the player's feet, but there's a window of time, a velocity that the camera can move up and down on. Right, so it's LERP smoothing region-based anchors with some manual control, right? So this is a motive that we'll see a lot, this smoothing, this camera smooth motion, particularly when you can move fast and jittery, when your movement is speedy. All right, snapping. So, sometimes the box metaphors can look jerky in their own right. So how would you describe this camera controller in Shinobi? How's it different from Fez? Yeah.
It looks like it's snapped onto the horizontal layer, but the player doesn't want to control the vertical side of the box.
Yeah, exactly. So it's position locked on the x-axis. The y-axis, there's some play, right? So eventually, that middle line, the center of the camera, moves to the player's feet. But it doesn't do it automatically. What's going on here? When does it move? How does it move? What's going on here? Yeah?
It seems to move whenever the player lands on the platform. It effectively raises their height to a new area again.
Exactly. So basically, when jump is finished, when character is on a surface, that's when the camera starts to readjust to the player's feet. And it does it with a constant velocity. Now, why? Why have this camera? Why do this? Let's see if we can answer all that questions. See if we can spread the love just a little bit. I appreciate it, though. Anyone have any ideas of why we do this? Why would we design in this way? How does it change gameplay? Yes.
I guess if the camera moved up immediately after the player jumped, it would be disorienting. It wouldn't feel like the player is actually moving.
Yeah, so this idea of like kinetic feel based on camera movement. That's definitely one aspect of it. What's another one? Do you have it ready?
Well, I was gonna say, like, there's that.
Oh.
I think to another extent, you also, since it seems to be like a level game, it's nice like you jumping and it feels like you jump on like your one level. If you're going to a different level, you want to get a good visual view of everything that's going on up there since you've shifted, you're in a new environment. So that's why at that point it starts moving the camera, so that you can get a good view of the enemies on that area.
Yeah. Anyone want to refine that a little bit? We got most of the way there. Yeah.
I feel like it keeps what's relevant on screen. Since when you jump to the next level, you don't care about the view stuff.
Oh, interesting. So my first gut reaction would be it's actually not showing you relevant things. Right? I mean, it eventually is moving up to show you what's relevant, but the design interpretation of this camera is you're actually jumping into the unknown. You don't have much information when you jump to a new platform. Like, watch this. You jump up, when the character was already physically present in that upper level, it was only the top like 5th or 6th of the screen. Right? Something could be falling down right on your head and you wouldn't know. Right? So this is actually adding a lot of danger and challenge to something you have to do in the game, which is traverse levels vertically. Just like Rastlin with the top left camera, Rastlin Saga, this adds the ability for ambush and danger. Does that make sense? Tracking? I wonder how many of you have played this game. You played this? Super Mario World, Super Nintendo? One of the more famous Mario games. Now Mario, it had a variety of levels. These are the vertically oriented levels where you're moving up and down. So what's this camera doing? Yeah? right? So there is no horizontal locking. The camera just doesn't move horizontally. But vertically, you jump into the unknown, into danger. And it's only when you land does the camera start snapping, start moving towards Mario's feet. Why? Let's reiterate the argument we've been making. Danger, challenge, information play. It's managing all of those things. And what's also added here is you're actually jumping into the region where there's a heavy user interface. So not only do you not have much screen real estate to see, that screen real estate is occluded with your number of lives, the number of coins you've collected, the number of stars, the number of like your auxiliary item, in this case the feather, time and score. All that's actually overloading your information channel as you jump up, right? All these add a little bit of challenge, a little bit of delay in your visual parsing of the scene. Yeah.
I feel like it can be argued that by keeping the camera static per jump, it might make because this seems to be like more pretty parkour heavy, so it might make movement more stable, where you're going.
Yeah. So not having the camera move a lot, like not having the camera constantly moving, probably helps you place set and reference set better on the platformer. Yeah. Good call. Good. Interesting analysis. Rayman. Also a very similar camera, although you'll notice that the camera moves a lot faster, snaps a lot faster when it's further away than when it's close. So there's a bit of non-linearity in the smoothing. All right, we have, Awesome Knots did this as well, right? So it had a Shinobi style camera. So once you hit the ground, the camera snaps quite quickly to show you where you land. But since you can float and you float upwards and downwards, you can really go into the unknown quickly. It adds danger. So a little bit about smoothing and small jittery camera motion. The pixels that we had in these arcade games, the older games we're talking about in the 80s and 90s, the screen resolution was much smaller. We had less pixels to work with. So every bit of movement that you had in the camera had to be mapped to a pixel movement. Pixel was the smallest quantity that you could move, that you could translate your game into. So every pixel that you mashed had a visible jerkiness to the motion. There was an inherent snapping to everything you did in those games, every motion. Now, when we talk about snapping in pixels in modern indie titles, they may have a similar number of pixel looking things, but each pixel there is a multitude of other pixels. Like one pixel in a modern, in a pixel art looking modern game is like, 16, 24, somebody's even 64 pixels wide on the screen. So you can actually do a lot of dithering, a lot of smoothing, a lot of fine, precise moving. If you had one pixel that was 8 by 8 pixels, one pixel representation was actually 8 by 8 pixels on the screen, you could move it by 1/8 increments, right? And not by entire chunk increments. So you could really, games now that have a pixel art aesthetic actually look a lot smoother than was even technically possible in the before times, the pre-COVID times. Which gives us a lot of things to do. It gives us a lot of ability to control with smoothing and physics. Pac-Land, one of the largely probably ignored spin-offs to Pac-Man. Pac-Man side-scroller where the ghosts are on pogo sticks, but you can still pick up the pill and make them run away. This is position locked with static forward focus, right? So no snapping here. It's very jerky. You move left, the camera moves left. You move right, the camera moves right. but add a little bit of physics. So notice that there's some momentum when Pac-Man starts and when Pac-Man slows down, right? So the momentum was baked into Pac-Man, and the camera was horizontally position locked. But then we get into the era of Shigeru Miyamoto, right? Here, we start having the NES titles that had like Excite Bike and Devil World. So a lot of these, we had cameras that were starting to get a little more nuanced than Rally X. Here was the first big mic drop in 2D camera world. Super Mario Brothers, Nintendo Entertainment System, the Famicom, 1985 for the US release, 1984 for the Japanese release, I believe, maybe 83. I'll have to look that up. What's going on with this camera? One, then two. Yeah?
You can't, it doesn't push box back. As in, like, you cannot move beyond the left side of the screen.
Right, notice the camera never moves left. Relatively. Same? Okay. Excellent. What else? What else is going on here? There are two lines. One's thicker than the other. You can't move left. That's what we got so far.
The timer starts going as soon as you slowly speed up the
Yeah, so the camera starts moving when Mario's going right between the two lines. Okay, that's cool. Why is it special? Exactly. It's not moving one-to-one with Mario's speed when it's in that zone between the two lines. The big thing that happened with this camera is this speed up zone between the two lines, which added a sense of drama, a sense of motion to the camera. So what's happening here is when Mario's moving right between the two lines, the camera is moving only a fraction of Mario's speed in the same direction Mario's moving, to the right. Which makes that whole buffer area, it gives it an area for the camera to actually speed up to finally, when Mario's center hits the right line, to match Mario's movement exactly. So every time you move to the right, not only does Mario have momentum he's building, but the camera's also building momentum on top of it. And this turned out to be probably like the most impactful 2D camera technology up until like the 2000s. Right? This was something that opened people's eyes up to what cameras could be. Out of all the interesting design elements that happened with this like seminal work, the camera controller is one of my favorite. The camera controller has magic. It was a intuitive, designful, like sort of like revolution in what camera controllers could do for a game. And it's also quite subtle. Right? It also doesn't dramatically change the experience of a platformer. It just enhances it. So, like, I can go on and on about the design of the jump, the design of the camera controller, eating mushrooms, all sorts of interesting things in this game. But this is one to be regarded, and will be the basis for the hardest stage in Exercise 2. All right, Metroid. Have any of you played a Metroid game? Yeah, Dread, Prime. This is the original, the one that kicked it all off. Metroid for the NES, 1986. This one has really like pull zones. It has two ways to use the camera. You can move up and down in two camera slices depending on the orientation of the particular level you're in. So it had a bimodal camera. And this is really interesting because Samus Aran has a lot. You have a lot of control, and Samus moves quickly and is a relatively large sprite for the screen space. All of those things make the difficulty high. Now, it would be almost impossible to play if the camera was constantly giving you eye fatigue and jittered. So this is also a very good camera for back in the day. It allowed you to move the camera and see a lot of information in regions you needed to see the information. Left and right on horizontal levels, up and down on vertical levels. So information play without jitter. It also gave you a lot of control over what you can see. It was very precise still. You were pushing exactly in directions that you needed to look. But this little buffer zone of camera not moving in the middle gave it a place to be static, gave it a place to be restful, gave you a way to really sit, analyze, and do minute movements without the camera messing with your movement perception. Right? So this is a very fascinating camera. And this is one a lot of games still use today. Okay, how are we doing on time? Okay, 15 minutes. Donkey Kong Country. Ah, the era of when 3D models were made and then rasterized and used as sprite sheets. This is a very prolifically ran speedrun game. A lot of people, like, this is one of their favorite games from the era. So what's going on with this camera? So we've seen all these components before. So why these elements in these configurations for this type of game? What's going on here? What's going on? Any intuitions? Yeah.
The camera's like slowly following the player, but the closer it gets, the slower it moves.
Yeah, right. And so when the camera slowly follows the player in games that have a lot of vertical movement, or vertical movement, what has that done for us in Shinobi? What has that done for us in I guess the several of the games we looked at, Rastlin? Information play and challenge, right? So it has that aspect to it. It also snaps like Rayman. The further it is away, the sooner the camera syncs up. And the closer it is, the less the camera syncs. So the more action and motion your character has, the more motion the camera moves. So the camera motion matches the player's motion, matches the kinetics that you're controlling at a time. The camera moves less when your player character, or when you're controlling what you're controlling, the effects of your controlling are less movement based, are less impactful, have less motion to it, right? So there's a designful matching of camera motion to player motion to play experience. Well designed. And so here's the basics of linear interpolation. We'll go over linear interpolation in class, but basically it's a way to move to map from one place to another space over time. I'm sure you've all seen normalizations or interpolations in your math classes. Linear interpolation, while we often call it linear interpolation, we often use interpolation kernels and have a sense of momentum. So we end up doing nonlinear interpolation and calling it linear interpolation in games. It's a little weird. You'll get used to it. We'll see how that works. All right, Super Meat Boy. Maybe we should make this a little bigger so you can see what's going on. Super Meat Boy. Image a new tab. There we go. Why this? This legendarily hard platformer with very precise movement. So the controls and the visual design of this game give the player a lot of advantages, right? The character is very small compared to the environment, so you have a lot of buffer space to work with. The character movement is fairly small compared to the size of the screen. You have a lot of real estate you can see all around the player. So why this camera controller for this game? This is the camera controller you're going to have to implement for exercise 2. So some things to think about. How far can the player get from the center of the camera? Right, not very far, right? 1/8 of the screen at most. So you're getting a little challenge. You're getting ahead of the camera a little bit. You're getting a sense of how kinetic and fast Super Meat Boy is. But you're still preserving information ahead of you. And the camera syncs up in a linear interpolated way. There's a window of distance that gets decreased over time, depending on the motion for the camera catch-up qualities of Super Meat Boy. It doesn't actually matter if you touch the ground before it starts snapping back to you vertically, before the character snaps back to the feet of Super Meat Boy vertically. So there's a lot of since this game can be very kinetic, you want to keep moving fast. It's a rhythm-based platformer where you're moving all across things in very precise ways, doing wall jumps, not trying to not get diced by whatever Saul wants to buzz you. So if the camera was position locked to the center of Super Meat Boy the entire time, this would be very jittery. It'd be a very annoying camera. There's a reason position lock cameras don't really exist anymore. This one would be a horrible game with that camera. This game probably would have been unplayable at the levels that Super Meat Boy is actually playable now. But the only difference is the camera. The level design could be the same, character design, difficulty, all that stuff could be the same. Without the camera, be bad news. So linear interpolation on both X and Y. Okay. Where did we go? Okay, that's right. That's right. We're up here. Super Meat Boy. All right, and so physics smoothing, like Never Alone. The camera follows where the motion of the fox, but has some momentum to it. So when the fox jumps up into the right, the camera moves up into the right, but if the fox bounces left, the camera still like has a little bit of momentum going to the top right, and then swings that momentum back down. So the camera is like, in some sense, being a trail to the fox, which adds a little bit of the camera is like playful with the fox. Is sort of like the metaphor here, right? And it's simple physics smoothing, just keeping position windows, and it uses an ease out interpolation. LERP, ease out. Ease out is nonlinear, so here we're already getting into nonlinear, linear interpolations. That's why you use like LERP without the acronym. Like LERP is just a different word than linear interpolation in games. Hyperlight Drifter. This game had pretty legendary physics smoothing. It was another game that pushed camera control technology forward. How many of you played Hyperlight Drifter? Yeah? Do you think the camera added anything to the game, those of you who played it? How do you feel about the camera? All right, let's examine why it's great. Let's thumbs up here. Right, so the character is actually quite big compared to the space around it. And there's a lot of danger, a lot of action, a lot of motion, a lot of lighting details to sort of like mess with your interpretation of safety of game actions. So the camera, while you can get ahead of it a little bit, smooths back quickly to the camera. You're never too far away from the center, so that helps mitigate the challenge of the game. And the physics snapping happens quite quickly and is smooth, which counteracts a lot of the jerkiness you would get with position lock camera, considering how almost instantaneous the jumps are in this game. The character is meant to be, hyper, meant to be like light speed style, popping through the world, like Tracer, right? Now, you can see this effect. So notice when the jumping happens, there's after image shadows happening to make it look almost like some sort of ninjutsu. If the camera followed that, you would instantly be snapping positions, and that would be very disorienting. It would almost be like you're having to reorient what's going on when a small teleportation happens. Right? That's very hard for people to deal with. This is why there's the physics smoothing, but the smoothing happens quickly. The camera moves very fast when the character jumps. Not instantaneously, but fast. So trails a little bit. So the camera is matching the gameplay and the difficulty of Hyper Light Drifter. So that's important when you're thinking about cameras. Matching your gameplay to the camera. Like having it be a counterpoint to either make it more difficult or offset the difficulty. Framing cameras, we'll go over this quickly. These are the classic shoot 'em ups or shmups. Life Force, Gradius, R-Type, Ikaruga, where you are being the level is being continuously scrolled, and you're able just to move sort of freely within that scroll space, right? Which is different than position locking, static forward focus, right? You can really see the difference between these. Now, one that's an interesting counterpoint here is 1981's Defender, where you can actually change directions in this game. This is worth opening a little bit and taking a peek. Oops. Great, so you can see what's going on here. You're the ship that's going back and forth, and as you change directions, you drift a little, right? This is maybe Fast and Furious 11 will be spaceships. I don't know. But you can see this moving back and forth has this sense of momentum to it, but you're still locked between these two positional areas. Right, which you can compare to this framing. It is a framed game, but the framing is different, right? It still auto scrolls to the left and the right, but you get to choose the direction it's scrolling. And you also have these dual focus controls in multiplayer as well. This is Bonanza Bros, a very early couch co-op 2-player game. And Super Mario World. You move left and the right, right? So what's going on here? How does this compare to that first Mario Brothers camera? Let's open it up and see. What do you think? I'm sorry, I was looking. Who had their hand up first?
So when you touch the edge points, it matches up with one in the middle. So it's like if you hit the left, then the screen will be more towards the right, and then if you hit the right, it will be more towards the right.
Exactly. Is that what you were going to say as well, or do you have something else to add? Okay, yeah. So why? Why do we mess with the formula? Why did we mess with the speed up zone? The traditional. Why do we have this particularly jarring camera movement when we hit that left edge or the right edge, the dotted lines? Yeah?
I think the game wants to show more of where the player is going. So when you're heading one direction, they position the screen so that you can see more in that direction.
Yeah, right. So it's also information play. It's also about the kinetics of movement, just like the original Mario Bros. Camera was about the kinetic of movement in that speed up zone. So what you're doing here is when Mario moves to the edge and you move quickly, the camera snaps back And so this has the effect of like signaling to the player that you're going pretty fast. You can move quite dramatically in this game, and this bouncing back and forth allows sort of like the information hiding as well as the kinetic motion feel of the camera to be preserved in bidirectional motion, which is different than the Metroid camera, which you pushed the box and had a dead zone. Okay, we're running out of time, aren't we? Yeah, we got 1 minute left. All right, there's plenty more here to look at in these camera zones, particularly the Jazz Jackrabbit 2 you probably want to take a look at. That's another one you'll be implementing. What's cool about this is the camera leads where the action is, so actively tries to provide you more information about the direction you're going, tries to give you more relevant information instead of making the camera make it more difficult for you. So it's like inverted Super Meat Boy camera. Target focus. So when you're moving your target reticle around, the camera follows the target reticle, makes it medium between target reticle and the player. Lots of interesting cameras here to look at. I encourage you to look through these. Not all of them move left and right. Some of them are diagonal focused. Plenty more to look at, but I think we covered enough for you to start exercise 2. All right. Office hours tomorrow. Mine and probably Kyle's. Good luck on exercise 1. Please post on Discord if you have questions. One moment, let me try the recording. Thank you all. Have an amazing weekend. I will see you all next week.